girls, right, now today we're going to look at ionic bonding, and we did one session on this before, but in this one we're going to look at how you can tell a compound is ionically bonded. We're then going to look at what happens to the electrons and finally how you'd work out the formula. So, Ms. McLaren, we've got 3 compounds here. How can you tell that they are ionically bonded?
Well, in this case, you have a metal with a non-metal, that's the oxygen, metal with non-metal, metal with non-metal, so we can assume they are ionic.
Right, so as long as a metal component is bonded to a non-metal component, it's ionic bonding. Okay, so we know with ionic bonding somehow we're going to make ions. What are ions, Ms. McLaren?
Ions are charged particles, and it's where the atoms gain or lose electrons.
Okay, so let's have a look at the electron configuration of magnesium. What is that?
It's in group 2, and the atomic number is 12. So the electron configuration is 282, but the idea is it has 2 electrons in its outer shell. 2
electrons in the outer shell. So if it's a metal, the number of electrons in the outer shell follows the group number. Magnesium's in group 2, so it has 2 electrons in the outer shell. What about the oxide, which comes from oxygen?
Oxygen's in group 6, and its atomic number is 8, and it has an electron arrangement of 2, 6, hence it's in group 6.
2, 6, so it needs how many electrons to get a full shell?
It needs to gain 2 electrons to have a full outer shell.
Right, let's have a look at a diagram here.
So, in this case, magnesium would lose 2, and it would actually give 2 electrons to oxygen.
So these are the 2 electrons in the outer shell. Oxygen has 6, could do with gaining 2 electrons, and it's going to gain them from the magnesium. So the magnesium is going to donate 2 electrons, are going to be transferred from the magnesium to the oxygen to make an oxide ion. Right, let's have a look at another diagram.
And we see if magnesium loses 2, it always becomes positive, in this case 2 positive, and the oxygen gains 2, so it's 2 negative, and because you only need 1 magnesium to 1 oxygen, the formula is MgO.
MgO, so just be careful, girls. If you lose 2 electrons, you become a positive ion. If you lose electrons, you become a positive ion. If you gain electrons, you become a negative ion. Okay, that's magnesium oxide. Let's have a look at calcium chloride. Let's do the same with calcium chloride. So calcium's in group 2. Excellent.
And it has an atomic number 20, but it's 2882.
2 electrons in the outer shell. What about the chloride?
Chloride comes from chlorine, that's group 7, and has 7 electrons in the outer shell, and it's 287.
Okay, let's have a look at a board for that one. Have you got one?
Right. I think I do.
Good.
So, here we are. We have calcium, which again you can see is 2 electrons are going to be lost. The chlorine actually wants to gain 1 electron.
So what's going to happen there then? If the calcium loses 2, they have 2 electrons floating around, they can be picked up, 1 each, by 2 chlorine atoms, which will become 2 chloride ions. And that means that we can work out the formula of that
So
compound.
that means calcium needs 2 chlorines.
Calcium needs 2 chlorines, so every calcium can attach to 2 chlorines. Here we are, so these become chloride ions. So it's CaCl2.
So that's 1 calcium, 2 chlorides.
Yes.
And that's the formula. Excellent.
Perfect. Let's look at the last one. Aluminium fluoride. Aluminium is in group 3. Therefore, Miss McLaren, there are
3 electrons in the outer shell.
3 electrons in the outer shell.
Which means it wants to lose 3 electrons.
Lose 3 electrons, so it'll become Al3 plus. Fluorine is in group 7, so it needs to
gain 1 electron.
Gain 1 electron. There are 3 electrons available, so how many fluorine atoms could be involved in this
Well,
process?
if it's 3 electrons and fluorine only needs to gain 1, then it would need 3 fluorines.
3 fluorines, and they'll each gain
1
electron. So,
if we look at this, that means aluminium is quite greedy, isn't it, really? So here we have aluminium given its 3 electrons, but it needs 3 fluorines to pick them up. Is that correct?
and they will become fluoride. Remember, for the non-metal, the ending changes when it becomes an ion, fluoride ions. So then we have Al3.
Excellent.
Anything else you'd like to add to this, Miss
Oh,
McLaren?
I think we've actually sorted this one out. What do you think, Dr. Bond?
Absolutely.
Great.
Okay.
Thank you.
Bye-bye.